Damn it, and welcome back to the channel. Today we're diving headfirst into the awesome world of electronics. We're talking about the little guys, the unsung heroes that make all our gadgets possible, diodes. These things are literally everywhere in our tech, from your phone to your TV, even your car. So what is a diode? In the simplest terms, it's like a one-way valve for electricity. Think of it like a bouncer at a club, only letting current flow in one direction and blocking it in the other. Buckle up because things are about to get shockingly interesting. To understand how a diode works, we need to zoom in, way into its structure. Imagine two silicon blocks, right? One is doped with boron, giving it a positive charge. The other block is doped with phosphorus, giving it a negative charge. And this is the N-type region with an excess of free electrons. Now, the real magic happens when we smash these two blocks together. This creates a neutral zone called the depletion. Remember how we said a diode is like a one-way valve? That's because of something called biasing. If the positive terminal is connected to the P-type side and the negative to the N-type, that's forward bias. The external voltage actually shrinks the depletion region, allowing current to flow through. But if we flip the battery, negative to P-type, positive to N-type, that's reverse bias. Current flow, not a chance. Now you might be thinking, so a diode never conducts in reverse bias. What's the point of that? Well, it's not always that simple. There are special cases, like Zener breakdown and avalanche breakdown, where a diode can actually conduct in reverse bias. This can be a bad thing, potentially destroying the diode, but it can also be harnessed for useful applications, like in voltage regulation. Chapter 4, Decoding the Specs. Key characteristics of diodes. Every diode comes with a data sheet which is like its resume. Understanding these specs is crucial for choosing the right diode for your circuit. Chapter 5, the diode family, from standard to superstars. Just like there are different players on a team, there's a whole family of diodes, each with its own specialty. Each of these guys has a unique structure and doping profile that makes it ideal for specific applications. Chapter 6, the PN junction in action, a microscopic ballet. When a forward bias is applied, the free electrons in the N-type region gain enough energy to overcome the depletion region and flow towards the positive terminal of the battery. Conversely, in reverse bias, the electrons in the N-type region are pulled away from the junction, making it even harder for them to cross over. Chapter 7, Diodes in action powering our electronic world. So, we've covered the basics of diodes, but where do we actually see these little guys in action? Turns out pretty much everywhere. They're the backbone of rectifiers, converting AC current to DC current, which is essential for powering most electronic devices. They're also found in signal processing circuits, clipping and clamping signals to prevent distortion. Chapter 8, the unsung heroes, Diodes' impact on modern tech. In a world increasingly reliant on electronics, diodes play a critical role. From powering our smartphones to illuminating our homes, diodes are essential components that impact our lives every single day. They may be small, but their impact on our technological world is undeniably huge. Outro, stay curious, keep exploring. And that's a wrap on diodes. Hopefully you guys found this journey as electrifying as I did. Remember, understanding these fundamental components is key to unlocking the secrets of the electronic world around us. If you enjoyed this deep dive into the world of diodes, make sure to give this video a thumbs up and subscribe to the channel for more awesome tech breakdowns. Until next time, stay curious, keep exploring, and always